Hey guys, this is Jay here and welcome to the channel ML Minds. So in this video, we will be learning one of the most popular algorithms in machine learning, which is K nearest neighbors. So we call it KNN also in short form. So we are going to implement it from scratch using Python's internal modules and using the numpy. So in the first part of this video, I'll be explaining the internals and the math part of the KNN algorithm. How does it classifies 2 points from being one class to another, and then later in the second part of this video we will try to implement it from scratch. So let's get started. So here I have a very nice example of a binary classification problem where I have a feature f1 and feature f2 on this axis, and here I have some positive data points in a blue dots and I have a negative data points also in a yellow dots. And here what we will try to do is we will try to classify a query point which is in a green point, and we will try to estimate whether it belongs to the positive class or a negative class. So what happens when we apply a KNN algorithm on a data set? So what KNN algorithm does is, so KNN algorithm tries to find a K nearest point from our query point. So let's say, for example, this green color point is my query point, and I have already trained my model before doing this testing. So let's say I have a trained KNN model on binary classification problem, and I have this KNN model already trained. And here this green point is my query point after training my model. And I want to classify this green point and try to find whether it belongs to the positive class or a negative class. So here what happens when we try to classify this green point? So let's say I have trained my KNN algorithm with k is equal to 3. So whenever we train a KNN algorithm, k will be our hyperparameter, and we try to tune it to get the best accuracy on the trained data set. So here in this example, I have taken k as a 3. So what it does is, for the green query point, it will try to find the most nearest neighbors from this green point. So what it does is it will try to calculate the distances of all the points from this green point, and it will try to sort the top 3 most nearest points to this green point. So in this example, let's say these 2 blue points and this 1 yellow point are the 3 most nearest point to this green query point. And then after it finds the top k nearest point, what it does is it will try to get the majority vote of those 3 or a k nearest points. So in this case we have blue in the majority vote. So what it does is it will classify this green point as a blue point, which is, it says that this green point belongs to the positive class. So this is how I have, and this is what I have explained here also. So it will try to find k points close to the query point to this green point, and then what it does is it will try to get the majority vote of k nearest neighbors. So if we have taken k as 5, what it does is instead of taking 3 nearest points, it will try to get the 5 nearest points, and whatever the majority class of those top k points. So let's say if I have taken as a 5, and in the 5k setting I'm getting like most 5 nearest points as and 2 of them is blue and 3 of them is yellow, then what I'll be doing is I'll be classify this green point as the negative point or belong to this yellow point class. So this is how it works. You can find the distances of this point from this green point so that we can find the top k nearest points. So there are multiple distance measures that we can use. So one of them is Euclidean distance, and there are others like Minkowski or Manhattan's distance also, that also you can use. But for this example, we will be going to use the Euclidean distance. So here I have one example of the Euclidean distance. So let's say this is my feature f1 on this axis and this is my feature f2 on this axis, and I have this point here x1 and I have this second point x2 here. And if I want to find the distance from x1 to x2, how do I do it? So this is nothing but a simple Pythagoras theorem that we can apply to find the shortest distance from point x1 to x2. So for x1 on the feature f1, what will be the point here? So it will be x11. So let's say it is x11, and on the feature f2 axis for x1, this is point x12, and same for x2 also. For x2, we have on feature 1, let's say this is x21, and let's say on the feature f2 axis for x2, this is x22. So how we can find the distance from x1 to x2? So x1 is nothing but a vector of point x11 and x12, and x2 is nothing but a vector of points x21 and x22, and d that we want to find is the length of shortest line from x1 to x2. So this is what we want to find. So this is nothing but the Euclidean distance. So how we can find it? So Euclidean distance d is nothing but the square root of x21 minus x11. So what we do is we try to subtract x11 from x2. So nothing but this distance. So we will try to find this distance, and then what we'll be doing is we will be doing the addition of x2 minus x12, and we'll be taking the square of them. So what in the second term here, what we try to find is the distance between x22 and x12, which is nothing but this distance. So the sum of these, both of this distance is nothing but this d, which is a Pythagoras theorem, and we call it as, and after adding both of these distances, we do it the square root. So this is nothing but the length of x1 minus length of x2, and in the machine learning we call it L2 norm also. So this is nothing but the length of x1 minus length of x2, which is nothing but this distance, right? So this is from origin. If we take the length of x2 and the length of x1 from origin, and if we subtract both of this, then what we find is the distance of x2 minus x1, which is nothing but this d, right? And we call it L2 norm also. So this is how we calculate the distance between one vector to another vector, or one point to another point in this 2D setting, right? So we can also use the Manhattan distance or a Minkowski distance, and there are like lot of other distances, but for this example we'll be using the Euclidean distance. So now let's try to implement it in Python. So now let's define our KNN class and add some most common methods, something like fit and predict, so that we can train our model and then we predict on the test data. So let's first define the KNN class. So here I have added KNN, and here let's define our constructor. So I'll be taking self, and k would be, I'm taking as a 3 for the default one, and here I'll be setting k as k. So let me erase this underscore, and then after setting k, what we want to do is let's define our fit method. So let's define fit method so that we can train our model on. So let's first add self, and then what we'll be taking as an input is two sets. One is the set of features, the data points of the features, and then the second argument will be the true class label. So here I'll be writing xtrain and then ytrain here, and let's set this to xtrain and then ytrain. So xtrain is equal to xtrain, and self dot ytrain is equal to ytrain. Okay, so this will be our fit method. So now let's define our predict method. So here let's define predict. So in the predict, what will be sending as an argument, which is the sample of test samples, right? So let's define it as x, and here what we have to do is first in the predict one, so we have to first calculate the distances in the test data and the training samples, right? And then only we'll be able to find the most nearest points, right? So let me take one variable here, which is a predictions, and I'll be using a list comprehension here. And what we'll be try to do is we will define one more method which will calculate the distances, and it will try to find the most nearest points. So let me define something like this: self dot underscore predict, and then in this we'll be sending one data point of the test data. So I'll be writing x here, and we'll be looping to each of the data point in the test set. So for x in x, so the capital X will be our test data which will be sending here, right? So now let's define our return method, which is nothing but this one actually. So this is giving me a suggestion. So this is what we want to add here, right? Because the prediction will be sending as a like numpy array, right? So it is giving me error. So let's import numpy here, import numpy as np, right? Okay, and then let's define our self dot underscore predict method. So here for let's define the predict underscore predict, and in this we'll be sending a point, right? So this will be our x, right? So what we want to find here is, so first we will be finding the distances, then what we find is the most nearest points, and then we will be finding the majority vote of those nearest points, right? So let me write it here: compute distances, right? And then in the second step what we'll be doing is find k nearest neighbors and their labels, right? But without the labels, how we will not be able to find what is the predicted label, right? Without the label we won't be able to find what is the majority vote, right? And in the third step what we want to find is the most common label, right? So let's say if like k is 3 and like 2 out of the 3 is blue label and 1 is the yellow label, so we'll be predicting as like we will be declaring it as a blue label or a true label or a, right? So this is what we want to find. So let's say, so I have another module implemented here to test this class, which is this KNN underscore test, right? So what I'm doing here is I'm importing some of the libraries. One is the matplotlib to plot the labels, and in the second one I'm importing data sets from sklearn, and then in the third one I'll be importing train test split. So we split our data in train and test set, and here what I'm doing is I'm loading the iris dataset. So if you don't know what is the iris dataset, this is one of the most popular dataset and like everyone knows it, and you might also be aware of this one. So this is nothing but samples of 3 flowers, which is Setosa, versicolor and virginica. So this is in the 3 classification setting, and here I'll be importing my iris.data and the target of those one, so the true labels and the sample points. And here in this one I'm splitting my x and y data set into the train and test set, right? So xtrain will be having the train features, xtest will be having the test features, ytrain will be having the true labels, and so on, like ytest also for testing. And here I'm having xtrain. So let's first see the shape of xtest. So if I run this, this is our shape, right? So let me stretch it more, and here we have 120 samples for training data and it has 4 features. So let's say one example here of one of our feature. So this is our feature vector. So this has 4 values, right? 5.1, 2.5, 3. And 1.1. So this will be our training data point. And here let's see how our ytrain looks like. So if I run this, this is how it will look like. So 120 true labels we have, and what is the first one is, this is the 1. So let's see what are the other classes we have here. So let me comment down this. Now let's run this. Okay, just a second. Okay, so here we have in the Y train is nothing but a row vector of 120 true labels, and this is how our Y train look like. So we have 0, 1 and true, which is nothing but a 3 class, right? So as I said, this is a data set when we have 3 flowers, which is versicolor, virginica and setosa flowers. But let's see how this looks like in 2D setting. So let me comment out this and let me uncomment this one. And now let's see how this data looks like in 2D. So let me run this. So this is how it will look like. So this is a red points and this is green and this blue point. So this is a 3 class setting, but we are trying to plot it in the 2D one. So this is how it will look like, right? And what we'll be doing is we will try to find this plane, or we'll try to train our model on this data, right? So let me close this. So now let's complete our predict method. So here let's get back to the KNN class and let me close this. So now let's the first step, which is to compute the Euclidean distances. So here what we'll be doing is let me create one more variable here, which is distances, and here let's define one more list comprehension. And here what we'll be doing is let's define a Euclidean distance method, like a global one, not in this KNN class. So let's me def Euclidean distance, and here what we'll be passing is, so how we calculate the Euclidean distance is nothing but the between 2 points, right? So let me pass x1 comma x2 here. So this will be our 2 points in which we will try to find the distances. So here I'm getting like suggestion again. So this is how we want to do it. So what we'll be doing is we are subtracting x1 and x2, and then we are doing the square of this one, and we are summing up the distances, and then we are taking the square root of them. So this is nothing but the example that we have seen earlier, right? So if I open it, so in this example we have seen it here, right? So what we are doing is we are subtracting x1 minus x2, and then we are taking the square of this, and at the end we are taking the square root of this, right? So this is how we will calculate the Euclidean distance between 2 points. So this will be our Euclidean distance method. So now let's define here Euclidean distance of this x, right? So this will be our test sample, right? This 1 point, and we have to find it in all the training samples, right? So let me define it x comma train here, and we want to calculate it for all the training samples, right? For x train in self dot x train, right? So this is how we calculate the distances. So we have the distances. So now let's find the k nearest labels and their labels, right? So how we are going to find those? So what we have now is the distances of all the points from this query point x, right? So we want to find the k nearest neighbors, like top k nearest neighbors. So let's first find the indices of those, right? So here I'm creating one more variable, k indices, and for this I want to sort this distances, right? So by sorting only we'll be getting the most k nearest points, right? So that's why I'm trying to sort this. So in this one I'll be passing the distances, and what we want is the top k nearest points, right? So this will be nothing but an array of sorted distances, but we don't want all the distances, we only want k distances, right? So let me here take this self dot k, right? So we have k here, right? So that's why we'll be only getting the most nearest k points, right? The indices of k points. Now let's find the labels of those k nearest points. So I'll be defining one more variable here, k underscore neighbors labels, right? Neighbor labels. And here what we'll be doing is we have to find the labels of those three nearest points, right? So I'll be defining one more list comprehension here, and how we are going to find it is we have to do self dot ytrain. So we have to find it in ytrain, right? And here I'll be passing I for I in k indices, right? So k indices has the indices of k nearest point, and those indices we will passing in the ytrain so that we get the labels of those nearest points indices, right? So this is how we'll be we can find the k nearest labels out of this k nearest labels, right? So let me define one variable here, which is predicted label, and for this how we are going to find it is let's use the Python's collection module for this. So let's import that first. So I'll be writing from collections import counter. So now we have the counter function here, and here how we are going to find it is for counter, and in here we'll be passing our nearest labels, and from this we want the most common one label, right? We want one most common label. So let me just give one example here for this one. So let's first import collection module here from collection import counter, and let's define one list here which is something like this, right? Now try to find the most common one here. So let me use this counter one, and we'll be passing the list A here, right? And then we want to find the most common one in the entire list. So now let me print this most common one, and if we try to print it, this is how it will look like. So we are having one list, and inside list we have one tuple here, and in the tuple we have 1 comma 3. So 1 comma 3 is nothing but the first one. The 1 is the element which is the most occurring in this list, right? So if you can see here, the 1 is occurring 3 times, which is the most in entire list among all the elements, right? And 3, the second element in this tuple, is nothing but the number of time 1 occurring in this list. So this is how it is giving the 1 comma 3. So if I enter 2 here, let's see what it gives. So now it is giving a list of 2 tuples, which is 1 comma 3, and then it is giving 3 comma 2, because 1 is the most occurring element which is occurring 3 times here, and 3 is the second most element which is occurring twice here in this list, right? And if we want to find the 1, so what we want is we want the most occurring element which is 1 here, right? And not the counter of that element, how many times it is occurring. So how we are going to write it is we want one element, and out of this list we want the first tuple, and in the tuple we want the first element only, right? So this is how we define it. So if we run this, this will give us 1, right? Because 1 is the element which is occurring most of the time. So I hope it is clear for you now. So let me erase this, and let's get back to our original example. So here we want the 1 common label, and in this one we want the first element of the tuple. So now let's return this, the predicted label, right? So I think we have all the necessary methods defined here. We are calculating the distances, and we are predicting the labels also, and we are finding the most nearest labels, and we are returning the predicted label also. So I think this is done. So now let's test this. So here back to KNN underscore test.py. So here what we'll be doing is let's import that KNN class first. So from KNN import KNN, right? And here let's define our model, which is nothing but KNN, and here let's use 3 here for 3 nearest neighbors, right? So we have the model defined, and let's try to fit it on our train example, which is nothing but x train comma y train, right? So we are training our model, and then for prediction, let's take one more variable here, which is y pred, and here let's try to predict our label, right? So what we'll be passing here is the x test, right? So this is the training data and this will be our test data. So we want the predictions of all the training test samples, right? And now let's find the accuracy. So accuracy is nothing but out of all the test points, how many samples our model is predicting correctly, right? So how we going to define is np dot sum of all the labels which is predicted correctly by model, right? So what we do is let's define y test is equal to y pred, right? So out of all this, how many labels or predictions model has correctly classified, and we want to sum them up. And now let's divide it by length of y test, right? And now let's try to print our accuracy. So I guess this is done, but it is giving error for np. So let's import np here. So import numpy as np, right? So I think we are done here. So now let's try to run this first. So let me run this now. And if we want, so this is giving us 100% accuracy, right? So now let's try to see what is giving for 5 nearest neighbors. So for 5, it is giving 96% accuracy here, right? Now let's try to find for 7. So for 7 also it is giving 100% accuracy to us. So it is predicting all labels correctly, right? All the test samples correctly. So yeah, this is all about this video, guys. And I hope you like this video, how we have implemented entire KNN algorithm using Python's internal modules and numpy. And I hope you understood how it is working behind the scenes, how we can calculate the distances from query point to the training samples, and how we find the k nearest neighbors, and we do the majority vote and we classify the query point. So if you have any doubts or if you have any suggestions, please comment down in the comment section below. And I'll be sharing this code snippet with you guys in the comment section below, so you can find the link to the GitHub repo to this code base. And if you like this video, give it a thumbs up and do subscribe to my channel if you have not done yet. We'll meet in the next video. Thanks for watching.